In this section, we're going to cover matrix inversion and how to use it to solve. Now, the key piece to this is we first just need to talk about inverse. Make sure we understand what the word inverse is. And most students, if you've heard this word before, you just have used it in, for example, you need the inverse operator. So if you were solving an equation, maybe it's 3x plus 4 equals 8, and you would say, okay, step one, subtract 4 from both sides. Well, why? Well, because addition and subtraction are inverses. The 4 was adding, the negative 4 will subtract, or minusing 4 will subtract, and those will undo each other, leaving you with just 3x. Those are inverse operators. Then dividing by 3, well, that's the inverse of multiplication. So that's why they undo each other. And we would end up solving, getting something like x equals 4/3. Now, matrices, we've learned how to add, subtract, and multiply. And the adding and subtracting work just like normal. If you add a matrix and you subtract it, they are inverses of each other. The process would just leave you back with what you started with. But multiplication had that crazy rows and columns and adding them together, and oh my goodness, undoing that would be challenging. So there is no division. There is no such thing. There is no way to actually have a division symbol. So instead, what they're going to do is just use what's called an inverse matrix. All right, so, but to get there, it's going to take a little setup. So the first thing is we're going to start off with matrix A, and we'll just call it 4203. And you could do this by hand. One technique that would work for finding any inverse matrix, and this is probably the easiest one at this point. The other ones all kind of rely on patterns. The easiest from what you know, or how you know to do it, it would be this. This is the process that somebody would go through. You are going to set up a matrix so it looks like this. The left-hand side would be the matrix you're trying to find the inverse of, and the right-hand side, this is a very specific matrix. This is called the identity matrix. Now, it's going to turn out to be useful, but not terribly important. The identity matrix, we typically use an I to name it because of identity, and it is any size matrix. It's always a square, so meaning it always has the equal number of rows and columns. Okay. But it's the idea here. Oops. Helps if I actually line up my rows and columns. Makes it a little easier to follow. The idea, though, is it's all ones and zeros. And the ones will always go in the diagonal. There we go. And the zeros go everywhere else. So that would be a very large identity matrix. Whatever this is, let's see, 1, 2, 3, 4, 5, a 5, 1, 2, 3, 4, 5. Good, it's a square. 5 by 5. But, so this one is much smaller. This one's a 2 by 2. So how you find a inverse matrix now is you are going to solve this using row operators like we did back in section 3 point whatever, or whatever book you're using. It's but you're going to go back and just do row operators until you have an identity matrix, on the left-hand side, or it kind of looks a little bit like reduced echelon form. And then what you're left with over here will be your inverse. Now, I don't really feel like doing that by hand. That seems like not fun. So instead, let's just do that in the calculator really fast. Let's go ahead and pop this into here. So we're going to go say edit. Okay, so to be able to type this matrix in, it would be 2 rows, and we're going to need 4 columns, and it would be 4, 2. Now, you can't really have the augmented bar. You can't have this bar in the middle kind of separating the two, but that's okay. We know. So we'll just go ahead and leave it alone. We know it's supposed to be there. Okay, then for the next one, we're going to do a 0, 3. And I always, before I move on, I always like to check and make sure these 2 columns are okay, because it's going to start moving them off to the side. So 4, 2, 0, 3. Perfect. Okay. So down here, we're going to do a 0 and a 1. Okay. So now, in my matrix A, I've got it all set up how I like it for this, to this process. So I can now go over here, go math, arrow over to reduce echelon form, and we're going to do matrix A, and voila. So now you can see my first two columns are the identity how I or the the identity how I wanted them. So now I just have my inverse to fill in. Now here we go. So what we're going to do here is we're going to say I want to change this to a fraction so it's easier to read. There we go. So this would be 1/4 -1/6 0 1/3. So what this means to me is multiplying by matrix A, whatever that is, this matrix of 1/4 -1/6 0 1/3. If I were to multiply it by that, it would undo the multiplication of A. Those are inverse matrices of each other. So okay, so what we're going to do now is we're going to figure out why we need it. Okay, now it would be useful. It would be useful if we had some set of matrices where we had like a variable matrix, like let's call it X because we always call our variables X, right? Because that's what we do in math. Everything's X's. Ugh. No. Anyway, but we'll call this matrix X. Now, so if you needed to solve for your variables, the trick here is we need to get rid of the matrix A. We need to move it from one side to the other. But the problem is like we said, there's no such thing as division in matrices. So instead, though, what we could do is multiply by matrix A inverse. Now you'll notice this notation, A inverse. This notation would be extremely similar to inverse notation with function notation that you learned in previous classes. So what we're going to do is multiply by the inverse operator. We're going to multiply by A inverse. So, but again, just like in all of algebra, if I multiply one side of my equation, I have to keep it balanced. Now, here's where things are a little different. This is where things are, you have to be a little careful. Remember we talked about order of multiplication. The order is important. You can't just multiply on the left or the right. In matrix multiplication, it matters. So I have to pay attention to which side I am putting my A on. So notice I'm on this side of the equation, the AX, I multiply the A inverse on the left-hand side of it, which means when I go to balance my equation, I also have to multiply on the left-hand side. So now, what we've already kind of talked about is A inverse times A. Those are inverse operators. So those are going to undo each other, leaving me with X. And then over here, I'd be left with A inverse times B. So that's why we kind of need it, is if we were going to solve for a variable, just like we did in algebra, we needed something in matrices to get rid of an A. We needed something to get rid of a matrix that was multiplying, and this does it. That's going to be our trick. So the notation, as we already said, it's going to be your standard inverse notation. All you're going to do is throw the little -1 up there. What is the key thing to make sure you do not do? That is not an exponent. Don't think that's a to the raised to the -1. No, 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 no. That is a inverse notation. Okay, so let's talk about actually solving it. Now, here's the fun part. Students, you look at this and be like, I already know how to do that. I've got substitution technique, I have elimination technique, I have reduced for echelon form, I have Gauss-Jordan. Why? Well, I know Gauss-Jordan's not our favorite, but we have Gauss-Jordan. Why do I need something else? And just say, because Professor Dwork says you do. No, I'll show you a problem in a minute where you actually do need it. But the idea for all of these things is we're giving you all these different techniques that are great in different scenarios. So you might look at this problem and say, I'm not doing matrix inversion. I don't want to do it. This does not seem like the most convenient way. I would agree with you. I probably wouldn't do it for this problem. But we're going to do it this way anyway, just to practice. So let's first talk about, all right, first thing we're going to do is I want to take this and write it in something that looks like that. I'm going to write it in what's called AX equals B form. Now, just follow along. I think usually I do one of them, and students just immediately will kind of pick up what's going on here. So, whoops, that's a 2. There we go. Now my next column is going to be X, or my next matrix is going to be X's and Y's. And then my last is that. So what you'll notice here is I was trying to mimic the form I showed up above. Some matrix A times some variable matrix equals, and then B, some third matrix. Now, you'll see the B matrix is relatively simple to come up with, as long as it's kind of written in this way. If your equations aren't written out in this format, rewrite them so they are in this format. But this column here is your B. Okay, so that's my B column. Then over here for the A matrices, notice I just grabbed all of my coefficients. I grabbed all of the 3, -4, -4, 6, 6, 2, 2. Okay, and you'll notice each row represents an equation. So equation 1 is row 1, equation 2 is row 2. Now, the one thing that sometimes gets students is to say, why did you write your variables vertically? Well, because I did matrix multiplication. If I was going to go row 1 times column 1, what would that result in? Well, 3x plus a -4y. And you'll notice, and that whole thing would equal -3. You'll notice writing it this way builds our equations. So it's just a way of taking your equations, there we go, and rewriting them in a matrix. There we go. Okay, it's and making it, I think, a different look, and you'll see it's helpful in certain scenarios. So now the question is how do I solve this? Okay, if this is matrix A, this is matrix X, and this is matrix B, how do I solve this thing? Well, it's actually very simple. I have to multiply by A inverse on the left-hand side, and to get rid of the A matrix to get my variables by themselves. But again, like we said in the previous up above, whatever I do to one side, I have to do the other. So I have to multiply by A inverse on the left-hand side again, which would result in X equals A inverse times B. Isn't that the same formula that we did above? Well, if we always take these equations and always write them in this format, won't it always be this for your solution? X equals the inverse of A times B on the left-hand side? Okay, so what we need to do, we need to find A inverse, and we need to multiply it by B. Now, so let me show you how to do this, find an inverse in your calculator. That's a little more simple because doing the whole augmented matrix is a little cumbersome. So the first thing we're going to do, we're going to go into our calculator, we're going to go to the matrices, and we're going to put in our A, just like this. We're going to put in a 2 by 2 matrix, okay? And we're going to put in our values, so it's 3, -4, 6, and 2. All right, now that's our matrix A. It has been put in, it is good to go. Whoops. But here's the issue. We also need matrix B because we have to multiply. So what I'm going to do here is go over to Edit. I'm going to arrow down to B. And our B matrix is a 2 by 1. And our values is -3. Whoops. Go to, I had a typo, -3. There we go. And 1. Okay, so now I have my two matrices in there. Now, how do I find an inverse matrix? Well, it's actually really simple, and it's really logical. Once you know about inverse and you know the notation, you'll notice on your calculator, the matrix button, the actual button itself is x to the -1. Well, that isn't actually for an exponent. That literally means inverse. So when you type in A, so let me go through that a little slower. We're going to go to matrix. I'm going to use the names for matrix A. I'm going to hit enter. Okay, so now I have A in my main little blinky screen, but I don't want A. I want A inverse. So if I were to press this little button, now when I hit enter, the calculator will spit out my inverse matrix. Now, we don't actually need it to do that for us, but if you, right now we don't, but if you needed the A inverse by itself, there you go. That's how we're going to get inverses in this class. You're just going to type in your function that you need the inverse of, you're going to hit the inverse button, and you're going to be done. Okay, but we can totally do this all in the calculator. We can do A inverse because we know how to do matrix multiplication in the calculator. So A inverse times B, we hit enter, and there's our answer. So what we have just solved for, what we just figured out, is this whole thing that will result in x, y, there's our b, equals, and if you need to, we can do a little fraction. This equals -1/15, 7/10. So what does that mean to me? Well, we were still solving the same types of problems we were doing in section two, in the previous sections. We're still finding an intersection of lines. So this, we can't leave it like this in the matrix. This would be inappropriate. But we know it's an ordered pair. We know it's something existing on the graph. And we know the x value is a negative 1/15th, and we know the y value is 7/10. So our answer is there. There's our ordered pair. All right. So big idea, big idea. We just learned another method for doing the exact same thing we already know how to do. Yay. Okay. That doesn't seem great. In the next video, we're going to go ahead and show you why we actually